Imagine a reality where space itself begins to violently tear apart before your eyes. Gravity is no longer a silent force, but a visible, overwhelming distortion of existence. The very fabric of the cosmos folds, crushing massive planets into absolute nothingness. Even light itself is trapped, spiraling downwards into a bottomless cosmic abyss. This is the terrifying, inescapable reality of extreme spacetime curvature. The gravity matrix. Today, we simulate the terrifying truth about spacetime, decoding the ultimate mystery of the cosmos. For centuries, humanity looked up at the night sky and perceived it as a static, empty void. We believed the universe was merely an enormous, unmoving stage where the cosmic drama played out. But the truth is far more complex. Space is not empty. It is a dynamic, interconnected, four-dimensional fabric. Imagine this fabric as an infinitely vast, highly elastic trampoline stretching continuously across the dark universe. Every single object that possesses mass rests upon this delicate cosmic trampoline, creating a subtle dip. For a long time, Sir Isaac Newton taught us that gravity was a mysterious tether pulling objects together. But Albert Einstein shattered this illusion, revealing a far more profound, geometry-driven reality through relativity. He proved a simple but mind-bending rule. Mass tells space how to curve, and space tells mass how to move. To understand this, imagine a massive, incredibly heavy bowling ball placed precisely in the center of our stretched canvas. The canvas sags deeply under its immense weight, completely altering the shape of the surrounding surface. If you roll a small marble nearby, it cannot travel in a straight line across the warped canvas. Instead, it curves and spirals inward, helplessly caught in the gravitational geometry created by the heavier mass. This beautiful geometry is exactly how our immense sun dictates the orbital paths of the entire solar system. Our Earth is simply that small marble, continuously rolling along the invisible curved groove created by the sun. But what happens to reality when the mass becomes unfathomably dense, reaching a scale beyond human comprehension? When a dying, supermassive star collapses into a singularity, the delicate fabric of spacetime literally rips open. The gentle cosmic dip instantly transforms into a bottomless, inescapable well, known as a black hole. Here, the localized gravity is so extreme that the curvature of space becomes an absolute, terrifying trap. Not even the fastest entity in the known universe, light itself, possesses the velocity required to escape. And as space curves infinitely toward the singularity, another fundamental dimension is aggressively dragged down with it. Time, the ultimate, unrelenting constant of our lives, begins to drastically slow down and stretch. Near the terrifying edge of this abyss, a single passing second could equal years back on Earth. This is the mind-bending reality of extreme spacetime curvature, a true mystery that defies human logic. To fully understand this abyss, we must venture closer to the event horizon than any simulation has ever dared. As our probe inches closer, the brilliant, chaotic halo of the accretion disk completely dominates our visual field. The intense gravity begins to aggressively warp the light of the stars, positioned millions of light-years directly behind it. This creates a mesmerizing, terrifying optical illusion, bending the distant cosmos into a perfect, glowing ring of fire. We are now approaching the photon sphere, the absolute boundary where light itself is forced into a circular orbit. If you could look straight ahead in this region, The warped light would allow you to literally see the back of your own head. Just beyond this lies the event horizon, the terrifying point of no return, where reality as we know it completely shatters. To an observer safely back on Earth, our probe would appear to slow down, freezing perfectly still right at the edge. They would watch us slowly fade into a deep, ghostly red as the intense gravity violently stretches the wavelengths of our light. But from our perspective aboard the probe, time continues normally. We plunge straight through the shadow in an instant. Inside, the curvature of spacetime becomes so unfathomably steep that it generates a deadly, crushing tidal force. The gravity pulling at the front of our probe is millions of times stronger than the gravity pulling at the back. This terrifying phenomenon is literally called spaghettification. Any solid matter is violently stretched into a stream of subatomic atoms. At the very heart of the black hole lies the singularity, a terrifying point where mass is crushed into an infinitely small space. Here, density becomes infinite, and the majestic curvature of space-time becomes a mathematical impossibility. At this exact point, all our known laws of physics, everything humanity has ever discovered, completely break down and cease to exist. But what if the singularity is not the terrifying end of the journey, but merely a hidden door to somewhere else? The equations of general relativity allow for an astonishing mathematical loophole, a bridge tearing through the very fabric of reality. We know this theoretical structure as an Einstein-Rosen bridge, or more commonly, a wormhole. Instead of traveling across the vast, flat surface of the cosmic trampoline, a wormhole punctures a direct hole straight through the bottom. It offers a staggering shortcut across the universe, potentially turning a million-year voyage into a matter of minutes. However, to keep this terrifying cosmic tunnel from collapsing under its own massive gravity, we need something entirely unnatural. We would require a substance known as exotic matter, an unfathomable energy source possessing negative mass. Instead of violently pulling space together like gravity, this exotic matter aggressively pushes it apart, keeping the throat wide open. If a highly advanced civilization could harness this terrifying power, they would not merely travel through space. They would conquer spacetime itself, instantly traversing across galaxies without ever breaking the speed of light. But wormholes are not the only way to bend the rigid rules of relativity to our advantage. Imagine entirely encasing a spacecraft in a specialized bubble of completely isolated space-time. By artificially compressing the fabric of space in front of the ship and violently expanding it behind. The ship itself does not actually move. Instead, space itself aggressively flows around the vessel like a cosmic ocean wave. This terrifying concept, known as the Alcubierre warp drive, could one day make faster-than-light travel a physical reality. But warp drives and wormholes fundamentally rely on the four-dimensional spacetime that we can perceive. What if our entire universe is merely a flat, microscopic surface floating within a vastly larger, higher-dimensional space? Advanced theoretical physics, like string theory, demands the existence of at least 10 dimensions to mathematically function. These extra dimensions are curled up so infinitely small that they completely escape our biological perception and finest instruments. To understand this, imagine trying to explain the massive curvature of a 3D sphere to a completely 2D drawing. To the flat 2D inhabitants, the sphere passing through their world would just look like a terrifying, spontaneously growing and shrinking circle. In the same way, Higher dimensional physics might be secretly interacting with our universe right now, entirely unseen. Cosmologists refer to our isolated 4D universe as a brane, drifting helplessly within a higher dimensional space called the bulk. This radical concept could finally solve the greatest, most terrifying mystery of gravity: why it is so impossibly weak. Compared to electromagnetism, gravity is trillions upon trillions of times weaker. A tiny toy magnet easily defeats the gravity of the entire Earth. Why is it so weak? Perhaps gravity is not inherently weak at all. It is simply leaking out of our dimension. If gravity is the only force capable of rippling out of our reality and traveling across the higher dimensions, its true, absolute strength is diluted across the vastness of the bulk, leaving us with only a faint cosmic whisper. This terrifying multidimensional leakage might also perfectly explain the greatest cosmic enigma of our time: dark matter. Galaxies spin far too fast. Based on the visible mass, they should violently tear themselves apart and fling stars into the void. Yet something invisible, something possessing immense gravitational weight, holds them together in a terrifying grip. What if dark matter isn't an invisible particle in our universe, but the gravitational shadow of massive objects in a parallel brane? The implications are staggering. If multiple universes float freely within the bulk, they could occasionally drift too close. A physical collision between two branes would release an unfathomable, reality-shattering amount of pure energy. Some radical cosmologists believe this catastrophic multidimensional impact could be the true, hidden spark of the Big Bang itself. Our entire existence, every star, planet, and galaxy, might simply be the glowing, cooling aftermath of a higher dimensional collision. And if this cyclic model is true, our universe has violently died and been reborn countless times in an endless loop. To visualize this ultimate reality, we must push our simulation to its absolute breaking point, zooming out beyond the observable horizon. As we scale out, the majestic, infinite web of our universe shrinks down into a single, fragile, glowing bubble. And surrounding it lies an infinite, terrifying ocean of other bubbles, a foaming sea of alternate realities. This is the multiverse, a sprawling, fractal expanse where every possible physical law and outcome becomes a terrifying reality. But returning to our isolated bubble, what is the ultimate, inevitable fate of our specific universe? Right now, an invisible, terrifying force known as dark energy is aggressively accelerating the expansion of space. The fabric of our reality is stretching thinner and thinner. The curvature of space will eventually become completely flat. Trillions of years from now, the accelerated expansion will pull neighboring galaxies so far apart they disappear entirely from view. To any hypothetical observer left in this distant, terrifying future, the night sky will be completely pitch black. The brilliant, glowing web of the cosmos will have been stretched so far that light can no longer bridge the vast emptiness. Within our own isolated galaxy, the last remaining stars will slowly exhaust their nuclear fuel and violently die. The universe enters the terrifying degenerate era, a cosmic graveyard illuminated only by the faint, ghostly glow of stellar remnants. In this freezing darkness, the supreme rulers of the cosmos are the supermassive black holes, violently consuming any wandering debris. But as Stephen Hawking mathematically proved, even these terrifying, immortal monsters are bleeding energy into the void. Through a bizarre quantum glitch known as Hawking radiation, black holes slowly evaporate, shrinking atom by atom. over an unfathomable span of time, trillions of years. Even the most massive singularities will completely boil away. They will vanish in a final, brilliant explosion of pure energy, the very last flashes of light in a dying universe. After that, nothing remains. The fabric of spacetime flattens out completely. The cosmic trampoline is finally still. This is the big freeze scenario. But the terrifying phantom of dark energy offers an alternative, far more violent end. What if dark energy does not simply push galaxies apart, but aggressively strengthens over time, accelerating infinitely? In a scenario known as the Big Rip, the expansion of space eventually overcomes the gravitational glue holding galaxies together. It tears star systems apart, flinging planets into the freezing void before coming for the planets themselves. Ultimately, the terrifying expansion becomes so strong that it rips apart the very atoms that make up reality. In the final microsecond, the fabric of spacetime itself shreds into an infinite number of disconnected, microscopic fragments. Whether reality ends in ice or a violent cosmic shredder, it is all perfectly dictated by the unseen geometry of the cosmos. Gravity, the invisible architect. It sculpted the majestic galaxies from the primordial dust, and it will eventually orchestrate their demise. From the gentle curve that keeps the Earth orbiting the Sun, to the terrifying abyss of a singularity, spacetime is the ultimate canvas. But as we conclude this simulation, we must pause to ask one final, mind-bending question about our existence. If we possess the computational power to simulate the terrifying geometry of spacetime on a digital grid, could a significantly higher intelligence have already simulated us? Are we living within an unfathomably complex construct? Perhaps the unshakable laws of relativity, the speed of light, and the curvature of space are simply the base source code of our reality. A cosmic operating system running silently in the background, keeping the illusion of our three-dimensional existence perfectly intact. The next time you drop an object, or simply feel the weight of your own body pressing firmly against the ground, remember that you are physically interacting with the deepest, most profound mystery of the known universe. You are not just feeling a downward pull. You are physically feeling the invisible, majestic shape of the universe itself. You are standing directly on the edge of a cosmic trampoline, helplessly rolling toward the massive gravity of our sun. The simulation of spacetime is now complete, but our journey into the unknown has only just begun. Until next time, keep looking up and keep questioning the fabric of your reality. Welcome to the Gravity Matrix.